Students, we are given this question, integral 0 to 1 over root 2 sine inverse of x divided by 1 negative x squared raised to the power 3 over 2 times dx. Now, foremost, what I would be doing, I would be making the substitution, let u be equal to sine inverse of x. Now, when I move sine inverse to the left, I would get sine u to be equal to x. Now, I would differentiate both sides. So, differentiating both sides, we get. So what do we get when you differentiate? Differential of sine u is going to be cos u times du. Differential of x would give me dx. Okay. So now we have a quantity like this. Now you have to know that we are going to be rewriting cos u in terms of sine u, because I don't have a quantity involving cos. So I know that cos squared u is 1 negative sine squared u. So cos u is going to be root of 1 negative sine squared u. X is sine u. So that's going to be 1 root of 1 negative x squared is equal to cos u. So in the place of cos u, I would be substituting. So if I were to take this as 2, so therefore 2 can now be rewritten as root of 1 negative x squared times du is equal to dx. So du is going to be equal to dx divided by root of 1 negative x squared. So this is the expression for du. Now we have been given 1 negative x squared raised to the power 3 over 2. So let me just resolve that quantity. So 1 negative x squared raised to the power 3 over 2 can be rewritten as 1 negative x squared raised to the power of times 1 negative x squared raised to the power 1. We know that a power m times a power n is a power m positive n. So that's why I'm rewriting it like this. I would be using all of these in this question. I've got limit 0 to 1 over root 2. In the place of sine inverse of x, I would be substituting u times. Now, I'm going to be using this concept. 1 negative x squared raised to the power 3 over 2 is written like this. So that's going to be root of 1 negative x squared multiplied with 1 negative x squared. So this can be rewritten. I'm not touching the limits. I'm just writing the same limits. So this is going to be u times dx divided by root of 1 negative x squared. This is one component. And this has to be divided with 1 negative x squared. So this is equal to integral 0 to 1 over root 2 u. Now in the place of dx over root of 1 negative x squared, I would be substituting this quantity. Okay, so that's going to be du divided by 1 negative x squared. So if you were to see 1 negative x squared would be, if I were to substitute in the place of x, I would be substituting sine u. So this is going to become 1 negative sine squared u, right? So this is rewritten as within the limits. Okay, I'm not placing the limits now because all the quantities have been converted to u. So we need to change the limits for u. So now the question becomes u times du divided by 1 negative sine squared u, which is going to be cos squared u. Now we have to change the limits. So when x is equal to 0, we need to know what happens to u. Sine u, if you watch here, sine u is x, but u is given to be as sine inverse of x. So I substitute the value of x. So u is equal to sine inverse of 0, which is going to be equal to 0. So when x is equal to 0, u value will also be equal to 0. So this is one limit we have found. Next, we have to find out when x is equal to 1 over root 2. So what happens to u? Now we know u is equal to sine inverse of x. So that means u is equal to sine inverse of 1 over root 2. So this means I move the sine inverse to the left. So that would give me sine u to be equal to 1 over root 2. tell me for what value of u sine u can be 1 over root 2. We all know u should be pi over 4. So the limits have now been changed. So this is going to be 0 to pi over 4. So now we can rewrite the integrand u times 1 over cos squared u times du. Limits are 0 to pi divided by 4. We know that 1 over cos squared u is equal to secant squared u. This is a formula. So that means we got integral 0 to pi over 4 u times secant squared u du. In the previous problem, I have shown you what happens when you integrate 0 to pi over 4 x times secant squared x dx. So the same is applicable for this. So for that, we add a result to be as pi over 4 positive log of 1 over root 2. So this is the result that we got. So we will be using this. The solution would now be rewritten as pi over 4 positive log of 1 over root 2. You can leave it here or you can simplify it further. We know that log of a over b, okay, let me put it down here. Log of a over b is log a negative log b. We know this. Because I know this, I can rewrite this as log of 1 negative log of root 2. Log of 1 is 0. So now we would have pi over 4 negative log of root 2. Now this is equal to pi over 4 negative log of root 2. Root 2 can be written as 2 raised to the power of, which can again be rewritten as pi over 4 negative 1 over 2 times log 2. Why do I write it like this? Because I know a times log b is log of b over a. I know this output, right? So because of that, this is the final answer to this question.